Hello everyone, it's February the 6th. Alright, let's do this. Sort character by frequency. Given S, sort in decreasing order based on the frequency of the character. The frequency of the character is the number of times. Return the sorted string. If there are multiple answers, return any of them. So tree should be EERT. 2 E's, 1 R, 1 T. Okay? So both are valid. So basically, we will do is, we get a counter, right? Sort it, but it has to be an array of array, right? We get an array of array. We sort it, and we then get it back into how it's supposed to. Okay, so we have an idea of how it's supposed to be done. Let's do this. This is 7. Okay. First of all, we say counter shall equal to new int 26. Okay, and then int I equal to 0, I smaller than start length, I plus plus, counter s dot char at I minus uppercase and lowercase English letters and digits. Damn. Change my idea. Maybe and digit. Oh, Jesus. And digit. With minus 0, right? So from 48. Let's just do 128. It'll be easier. It'll be easier, yeah. So we don't even have to think too much. Oh, hold on. 128. Okay. And this will just be... Oh, what will just be that? The char. Right? It would just be the char, because if we do 128, it should just be the char. Plus plus. Okay? Once we're done, we need to do a int, right? This is a counter. This is frequency. Sorted frequency. New int 128 and 2, right? Then we say for int I equal to 0, I smaller than counter the length, I plus plus. We say sorted frequency I equal to, well, I can say it's 0 shall equal to counter I, and sorted frequency I 1 shall equal to I. Okay, and then we say arrays dot sort. Can we do sorted frequency? I guess we can. And then once we sort, how do we do reverse? sort array, sort in reverse. Okay. So we say collections. Can I do arrays dot reverse? No, it doesn't have. Collections dot reverse order. Okay, and then we're gonna go from front to end for, no, we have to say stream builder, stream builder. Huh? Stream builder res, new stream builder. Okay, and then for stream builder Java stream builder repeats. str.repeat. New char.replace. Ah, interesting. There's a repeat. Okay, we're gonna try that. But anyway, what we need to do is for I, go to 0, I smaller than sorted frequency dot length, plus plus. If sorted frequency, I, 0 is frequency. So if this is equal to 0, then we break. Okay. Otherwise, we'll say res.append sorted frequency I. Oh, this is gonna be a character. How do I turn it into? Char into string. String the value of. But string the value of char. Character.toString. Okay, I need to check. Because for me, it's hold on, let's go JShell. String dot value of, let's say, ask the table 79. 79. The character dot value of 79. Oopsie doozy. This is sort. Character.toString. My bad. Character.toString. That's okay. We're gonna do character.toString. Okay, we're gonna do character.toString. So we're gonna do this is gonna be 1. Right, we're gonna do character dot to string sorted frequency I 1 dot repeat. Do we have repeat? Yes. Sorted frequency I 0. Right, so we're gonna append this, and then we're gonna return rest.toString. Okay. Try this. Cannot find symbol. Cannot convert class to. I probably cannot. Oh, hold on. Java sort array of array. Probably having to do something like this. Oh, here. Okay, so first of all, there's an int here. Yeah, probably I cannot use this. So I can say ab integer.compare decreasing, we go b0, right, and a0. Okay, let's try this. Oh, looking good. So we need to say this is a sort frequency and decreasing. And I wonder whether we even need this. We can probably just get frequency, right? Yeah, we can probably just get frequency. Okay, frequency as we go through. Yeah, I think I don't even need this. I don't think I need this. I can just go through. I can say sorted frequency dot length. No, that's not true. It's s dot length. Right, this is s.char@. All right, 0 plus plus, and this is going to be s.char@. s.char1 shall equal to s.char@. I. Something like this. Yeah, I don't need this. Get the frequency of each letter, sort them, and then print and then produce a new string with frequencies in reverse order. It's not really O(n) log n, it's just O(n). Right, that's O(n). Sort is O1 because it's 128. And we have to do this is again on, so it should be on. Yep, pretty good. Yeah, that's straightforward. Counter the items, sorted reverse true for this. Yep, it's a one line. Python can do it in one line. 2021, 2022, 2024. Okay, done with this. All right, now we're gonna read. We know the solution. Now we can read this. Frequency of each letter, each path from root to node. This is what inspired me. This line, just this one line. Indeed, only the parity matters. So we can use bit mask and save bitmap and then set bits or letters. No UMV is valid if and only if there is at most one letter that has odd ES. For each letter, its frequency on UV path. Root to U, root to V, minus 2, is the lowest common ancestor. Only consider the parity. I think they just did one DFS and then it done, right? For each mask value, before updating it, we need to consider how many previous values masks that have. Just query the hash map. How did you do this with one? Okay. This is to build it up, and then from top to bottom, if x otherwise r plus equal to DFS all the children. And how do you pass the first one? Zero, zero. 0, 0, S. CON is adjacency list. Have is a mask. And then first is not. And then we just put Y mask S can have. Okay, so next value is good. Mask we add whatever it is to it, okay. I is this. This is a go through. I left shift 1. Right shift 1, okay. For each one, we'll try mask is the current. That is, wait a second. So we only go DFS from top down, right? So as I go through, and on first path, every time we go down, for each one of them, we check, right? We check. And this one, okay, is good. And then I keep moving down. Okay. And then that I need to check. Because the previous one's already in, so as I go down the one path, because the previous path is always in, so I can get all the ones here. But I cannot get overall. But we don't need overall, because once we get to the other path, the previous one will be in it, so I can, that's how they avoid duplicates. We just DFS. Damn, that's smart. Damn, that's smart. I don't have to do the way I do. Okay, this solution is inspired by advertisement. Huh. What is this advertisement? Okay, the general idea is the same as solution 1, but we only need to do one round of DFS. Okay? As we perform DFS, we also do the computation as well. We also keep track, right? We also keep track of the counter, right? Of all the bit masks, and count the number of palindrome paths ending at each node. Now, by the beauty of counting while DFS is that we can easily avoid duplicates because when one path is considered, how do I say it? Because when one path is considered, a potential, a possible, right? Because the paths, right? Because the paths are created gradually, which means an earlier path never has access to a later path, right? To even offer the opportunity for duplication. Yep. All right. Now what we're gonna do is I'm not a pro. For sure I'm not a pro. All right, now we're gonna produce the what do we produce? Adjacency list. Okay, so we can call it adjacency list shall be default dict of a list, right? And then all we need to do is just get the adjacency list up. So for I in range 1 to, okay, I also want n equal to len parent, okay, and we're gonna call it n adjacency list. This is going to be parent I, okay, dot append I. That's it, right? We don't have to do another way. We don't have to do like the path, the path character as well. We don't need. And then we need a counter, right? We need a counter. So we can say path counter equal to counter, okay? And then path counter, what else do we need? I think this will be it. And then we're gonna define a DFS. So we need a node, right? We need a node, and then, damn, that's the only thing we need. I don't think we need another thing. We just need a node, right? And we're gonna return the result. Okay, we're gonna return the integer result. And now we have a DFS, okay? And then we can say result is 0 for the inside, right? For the inside. And then we say if node, right? Because we cannot do 0. So if node, I need a path. Okay, so I need a path. Ugh. I need a path. Path is gonna be an integer. Okay, so if node and path shall equal to exclusive or equal to, so we need a new path. It's gonna be one left shift what? S node, probably ord S node, okay, minus is it lowercase, right? Lowercase is 97. Okay, so we get the path. Then we need to check. We need to check the allowed. Don't forget. Don't forget path counter 0 shall equal to 1. This is needed. This is because we want to check on path, right? This allows the detection of palindrome path from root to a node. Okay, all right, so with all that, I shall do allowed parodies. Okay, so we have one left shift. This is really smart. One left shift 26, right? We start from here, then we start the left shift. So one left shift 26. Well, hold on. We'll run one left shift 25, because we shift 0 and a 1, 2, 3, 4 all the way to 25, right? So one left shift 25. And then what we need to do is call while allowed. This is completely copying the other solution. While allowed parodies, then we can do allowed parodies exclusive for path, right? So what we do is call res plus equal to path counter, right? Path counter here is going to be the current path, exclusive or allowed parodies, right? So we plus equal to that. Okay, so once we go through all and then allowed parodies, I think it's right shift equal 1. I think that's the syntax. I'm not 100% sure. But we need to right shift 1, right? Right shift to 1, right shift 1 until we end. And this will give me all allowed parodies. And then we're going to check and then we're going to add. Right? We're going to add. Once we finish that, then we need to put path counter, because we need to add a current path. Path counter, the current path, this one gonna plus equal 1. Okay, so that's if we have a node, right? If node is good, we're updating all the results. And this is for the current, okay? Then after we finish what we have, and now we are going to for child in adjacency list node, okay? And each one we need to add as well, because I want this function to return the total number of palindrome paths. So here what we do is to count the number of palindrome paths ending, right? Like one end is going to be node, okay? We figured all those out. And then here is the children, right? My children. So I need to add all of them. So that's just going to be DFS, my child, and the current path, right? Current path. So once we're done with all of those, we're going to return res, okay? And we're just going to return DFS. We're going to start with 0, and we are going to say the path is 0. Okay. Oopsie doozy. We have to do multiple times. All right, is this correct? Ugh. Is not correct. Where did I do wrong? Where did I do wrong? I thought I followed everything. This is fine, right? This is the S node, right? Node is 0, path is 0. S node minus 97 is lowercase a. Yes, 97 is lowercase a, so that is fine. And then allowed parity. Okay, this might be, it is one left shift, down shift 25. Okay, and then 24, and then the last one is, because you one left shift to 0 is just 1, right? So it should be fine. And for each one, we're gonna do path exclusive or allowed parodies, the current parodies, and then this one gonna right shift 1. And once we're done, the current path is gonna plus equal 1. I set this. Interesting. All right, let's take a look. Where did I do wrong? This is fine. This is fine. Mask exclusive or. This is fine. 125 is fine. This is fine. This is fine. Plus equal to. This is fine. I have that. What is this? And then this is plus this. It is almost the same. I'm missing this one. What is this? This is the R plus equal to have dot get mask. Why would you do a mask? Why would you do a mask? Mask is the current path. Why would you do that? Path exclusive, okay, this is fine. And I right shift 1, I did that. And then at the end, the path counter plus equal 1. I think the only difference is I didn't do this. And I don't understand why you would want to do this in the first place. It does not make sense. Why would you get mask? I don't understand this part. But my problem is I have not enough. Dude, I have not enough. I do not have enough. Okay, so I have a path coming in, right? The first path is fine, and then I go through all the parodies, and I will find the one. Maybe the problem is you should, because allowed parody 0 is allowed parody, right? Maybe you didn't do that. Maybe you shall do the allowed parody is 0. What do you think? Allowed parodies. Yes, I did not do 0. I did not do 0. I think what I need to do is if then why you do 0? Path counter 0 equal to 1. Well, path counter 0 equal to 1 is if the allowed parodies is equal to path, then I can get it, right? I can get it, which does make sense, right? Which does make sense. Why do I need to add a path? Well, so we have the first one. Okay, so let's say 0, 1 comes in. Okay, because that's the first one. 0, 1 comes in. I obtain the path. The path is 0, 1, which is a C. And then I go through this, right? Which starts from 1 left to shift 25. And then that one does not exist, right? That one is not until this one goes to C, right? Until this one goes to C, then this will give me, when this one goes to C, this will be 0 because the path is a C, this is a C, and it's a 0. A 0 set to 1, so this shall give me 1, right? This is 1, and that's it, right? That's it. You know what? We can actually try this. Hold on, we can try this. How are you going to try this? I want to print out after this is done. Okay, so I want to print the node, okay, the node, the path, the node, the path, and what? The node, the path, and the result so far. And I'm not using this, I'm using this. And I'm gonna save this. Okay, let's try this. Oopsie doozy, this is not right. Okay, so with 1, that's actually not good to see. I'm gonna bin this. I want to bin. Okay, I want to bin this to the end. Okay, so 1, 3, 4, 2, 5. Okay, 1, 3, 4, 2, 5. 1, I get count as 1. 3, I got count as 1. That's true because for 3, the only count is 1, 3, right? And for 4, I got a count of 1 because for so far it's just a B as well. Okay, now for this 2, I got a count of 2. It shall get a count of 1 is this, and 2, 0, 1, 3. Okay, That's 2. 1, 2, 3, 4, 5, 6, 7. And for here, I need to get this. I have. See, that's the problem. 5 should give me 3. This one should give me 3. Because I can do this exclusive of this. Right? Yeah, that is not right. That is not right. So I have the path is 101, right? This is a 101. And in 101, when I go in, oh, 0 is not in this. 0 is not in this. I shall allow 0 in this. Right? You should allow 0 in this. Which means, oh, sorry. Which means the parity, Parities shall have 0 in it, right? Because allowed parity 0 is an allowed parity. And then if your path, right, exclusive or 0, right? Okay, let's try make this change. Allowed parity. Let's do allowed parities shall equal to, for I in range 26, right? And here is just going to be 1, left shift I. And allowed parities dot append, put 0 in. And here we don't do this. We simply say for allowed parity in allowed parities. Okay. And this one is going to exclusive or allowed parity. We don't need this. And then, okay, let's try this. So now I include everything in the allowed parity. Is this one right? Okay. So far looks so good. Actually, I need to test this. So I have 3 test cases here. Okay, I have 3 test cases here. And let's run this. All right, this one looks good. This one looks promising. Let's go. Yep, this one got it. This one got it. Yeah, we can only do it once, so we got a lot faster than before. And also the analysis of time complexity is also easier. Okay, so yeah, that's that. Good question. Good question. Top to bottom. I don't think I need to keep this one. Right? I'm not keeping this one. But this is still, oh, that's why. The get mask. This still doesn't make any sense. Right? This one still doesn't make any sense. The get mask 0? Like what? I don't think this one's right. Right? You're just counting the mask. Oh, it is right, because when you do get mask, which means if it exists already, then you do have, okay. Yep, good. I agree. This is correct. This is correct. But I want to do it my way, right? It's simpler. Simpler. Bravo solution. Oh, I already cast my vote? Okay. All right, done. Let's move on. I think we have time for one more. I want to try one more. Okay, let's try one more. Well, okay. Can do this. Cannot do this. Oh my god. Oh my god. Oh my god. Everybody is locked. All right, let's just do this then. Number of employees who met the target. N employees in a company numbered from 0 to n-1. Each employee I has worked hours I hours in the company. The company requires each employee to work for at least target hours. You're given a zero-indexed array for the hours, which is each employee has worked for that hour, okay, and a non-negative target. We're going to return the integer denoting the number of employees who work at least. Dude, they're kidding me, right? This one I probably, okay, let's just still that's what we're gonna do. This is not for here. This is just gonna be LeetCode 2798.java. Right, 298.java. 20J v1234. Remember. So basically, what we're gonna do is just count how many elements in the array is larger or equal to the target, right? I don't think we can do one line, can we? Maybe you can do reduce. Reduce, and I guess you can reduce. Yeah, let's be adventurous. Java, does Java have reduce? Stream.reduce, 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 stream API. Okay, we have this. Result equals numbers.stream.reduce. This is the, okay, can I use integer, or it has to be an array? No, it has to be a list. Arrays dot as list. Yeah, I feel like you have to turn into a list. Has to turn into a list. I think I've checked this many times. I still don't remember. Convert array to list. I've checked this many times. Still don't remember. That is not possible, because there has to be integer for this to work. Because here is int, so it doesn't work. Arrays dot stream dot numbers. Ooh, you can do streams here. Maybe I can do streams. Yes. Can we do this? Can we say arrays dot stream hours? Okay. Dot reduce. Yes. And I need an operator here. How do I do reduce? Reduce we need a start. Start is going to be 0, and I need a function, right? So we're going to say partial and hour, okay? And we'll say partial plus hour larger equal to target, then 1, otherwise 0. And maybe we can return this directly. Holy crap, I think this will mark my very first one-liner in Java. It works. Holy crap, it does. I think it works. Oh, it does work. But it's slow. It is slow. Okay, so yeah, this is the very first Java one-liner solution I have ever written. Kind of slow though. But I wonder if we don't do this one-liner trick. What will it be? Let's do one. Let's do another one. Okay, so we're gonna do this. We call it solution 2. Let's just don't redo everything. Okay, I will do a counter. Right, call it result. Okay, res equal to 0, and we say for int h of hours, res plus equal to h larger equal to target. If it is, it's 1, otherwise 0. Okay, and then we will return res. Okay, I'm just curious. What the performance is gonna be for this one. Should be right as well. Solution. Yeah, will it be faster? I think the stream or whatever it is, just making things slow. That's making things slow. Much faster. All right, that will be it. Good. I'll stop right here. All right, see you guys tomorrow. Adios.